In this video, I'm going to walk through chapter 2 and 10 as a brief overview to help you kind of prepare and focus your study before taking the exam. So we're combining chapters 2 and chapters 10, and we're not doing every section of each chapter. And we're focusing on atomic structure and then nuclear chemistry. So let's start with atomic structure. So the atom in general is going to have this picture of, we'll do it right here. We've got this tiny nucleus that has protons and neutrons in it. And then we have electrons that are making up the kind of volume of the atom. And so those neutrons and protons really make up the mass of an atom. And the electron cloud makes up the volume of an atom. And we're not going to get in too much more detail than that. The book does go through, and I have notes on it, but not lecture notes, on determining for each electron its electron configuration. If you are looking at taking a nursing exam later on, some exams have one question on this, so it's worth reviewing. But otherwise, you won't really be using it again, in my opinion, unless you switch majors and go into chemistry. So thinking about the nucleus, this is going to be comprised of positively charged protons and neutrons, which don't have a charge. So I don't know how to say, we'll do it like a 0 for the charge. And they both have a mass of about 1 atomic mass unit. And an atomic mass unit isn't a metric unit, so it's not like a gram or anything like that. The electrons around the nucleus, they have a negative charge, and they have basically a negligible mass. It's just very, very small compared to that of a proton or a neutron. So it kind of becomes a rounding error. And these really take on this electron cloud property. And we won't be able to go into detail on that. But because an electron is so small and has such a small mass, it's really impossible to know too much about it. We can usually know its position or its direction and velocity. And because we can't know both of those, we have a way of calculating the probability of where an electron might exist. But we don't have a clear picture of its behavior. So what to know about an atom coming out of this chapter. For any atom, you should be able to tell what the element is. And this is determined by the number of protons. You should know its isotope. And this will be information that's given to you. You can't look this up on a periodic table. This is about the ratio of protons to neutrons. And so for any given element, it'll have a number of isotopes, and each isotope will have a different number of neutrons. And you should know the charge. So if it is neutral, then you have the same number of protons as electrons. If it's negative, then you have more electrons than protons. And if it's positive, you have more protons than electrons. And that value, like let's say we have something that's +2, that means we have 2 less electrons than protons. And so our charge is going to really be dictated by that number of electrons, which kind of pairs in here with that electron cloud. And so if I give you a mass number, that will tell you, let's connect these. A mass number will tell you the number of protons plus neutrons. That's how we track what isotope we have. And that information isn't on most periodic tables. Sometimes there's a list of common mass numbers. The protons of an element you'll find from the periodic table. This is listed. This is called the atomic number. And then the number of electrons will always be given as a charge. That will be on the upper right-hand corner of your element symbol. That might be worth saying right here. So if we had an element symbol X, we can use all 4 corners of this to give someone information. We'll put our charge up in the upper right-hand corner. we'll put the mass number in the upper left-hand corner, the atomic number in the lower left-hand corner, and the mole ratio in the right-hand lower corner. And this mole ratio, we'll talk about that in chapter 3 and 5. So not quite yet. So looking at the periodic table, we should be able to take that atomic number and determine what the element is. And then the other thing that we'll know from the periodic table is the atomic mass. And this will be a number that actually has a decimal place typically, unless it's very large and unstable. And this is the actual weight of a sample of atoms, like an average weight. It's really a weighted average of all the common isotopes. If you remember weighted averages from your math class. And so we can calculate the atomic mass if we know the relative abundances of our different isotopes for that element. And that's what that number will equate to. The periodic table, I would also like everyone to be able to navigate somewhat. And so this is going to be knowing the difference between metals, nonmetals, and metalloids on the periodic table, just being able to look at where element is located on the periodic table and then determining if it's a metal or non-metal. That'll be really important when we talk about bonding. Also, there's a lot of information from the group. And I don't need you to memorize the properties for these by any stretch of the imagination, but it's good to know some of the general characteristics of each group. And so within that, we'll have ones that are important, like the halogens, noble gases. The transition metals aren't a group, but they're kind of like a series of groups. Then we also have our alkali earth metals and our alkali metals.